everybody. Today we are here to talk about quantum physics. Oh my God, this is a difficult subject, but we are going to make it as easy as possible. So Dan asked me the other day who I am to talk about quantum physics. That is a very good question. Well, I am, as I said, I'm not a doctor in quantum physics, but first of all, the first contact I had in quantum physics was in my career in computer science. So I'm not a doctor in quantum physics, but I am an engineer. And in the last year of my career, we had an optional subject where we talk about weird things. And one of those were some quantum physics things. For example, the teletransportation. Do you know that teletransportation exists? Did you know that? But I'm sorry to disappoint you, this is not like a Star Trek. That cannot be. I'm sorry. So the teletransportation, you need, for example, it can be done with a photon. A photon they are the particles that compound the light, right? So a photon, if you have a photon, you have two actually, and then you separate them. And so they don't teletransport. What it's teletransport is the information. So if you change, if they are, it is called they are tangled, okay? And then you change the information, you can separate, I don't know, hundreds of light years or anything. And then you change the information in one of them, and automatically the information in the other one changes as well. So that is a teletransportation. That is actually not the most useful thing in quantum physics. However, thanks to quantum physics, we have nowadays many things. For example, Wi-Fi, or when you cross, you pass a door that opens automatically. That also uses quantum physics, and many others. I have prepared a presentation that let me share with you. Okay. Okay, I'm going to share my screen. Where is it? Here. Okay, as you can see here, that is at least when I studied quantum physics in my school, when I was much younger, that is the atom that we saw. But however, that is very far from reality.
Yeah.
This is not, this is actually the proportions of an atom. So as you can see here, the nucleus is that small comparing with the whole atom. If you have, for example, the whole solar system, the nucleus, I mean, if the whole solar system would be an atom, the nucleus would be the sun. And one electron would be Pluto. Or if you want to have another approach, if the Earth would be an atom, a football stadium would be the nucleus. And a very tiny grain of salt would be an electron. So that are the real proportions of the nucleus within an atom, the nucleus and the electron. That means that the most of the atom is empty. So we are made of atoms, right? So we are mainly made of empty space. We are going to see a video that is going to explain this in a very few minutes. Can you hear that? Yes?
Yes.
Time, space, and matter. Matter seems like a good place to begin. The solidity of the world seems totally indisputable. As a fixed thing that you can see and touch, your body is also reassuringly solid. But beginning with Einstein, modern physics has assured us that this solidity is a mirage. After all, the body is made up of atoms. These atoms are particles that are whirling at lightning speeds around huge empty spaces. And the particles aren't material objects. They are fluctuations of energy and information in a huge void of energy and information. If you could see the body as it really is, you would see that 99.9999% of it is mostly empty space. And the 0.00001% of it, which you see as matter, is also empty space. The matter is just an illusion, an artifact of our perceptual experiences. As you sift through this very solid-looking material body, you only have to go so far before you end up with a handful of nothing. This is a scientific fact. The question is, what is this nothingness? What is this empty space that makes up everything in existence? Because it's very clear that the basic raw material of the universe is that it's not material. The essential stuff of the universe is non-stuff. Because an atom, which is the basic unit of matter, is not really a solid entity. It's a void. But is this void an emptiness? Or could it be the womb of creation itself? Could it be the source of life itself? Is this non-stuff, non-matter that makes up the entire universe just emptiness? Or is it thinking non-stuff, thinking non-matter, that curves back within its own self and creates everything in existence, from matter to energy to time to space? As you dissect through the body, the various layers of organs, tissues, cells, molecules, and atoms peel away until at the subatomic realm, all that remains are bundles of energy vibrations. The nerve receptors in the body are switching stations that can take energy vibrations and turn them into touch, sight, sound, and so on.
So, you are energy. All is energy. What is that? Because there is something called duality wave-particle duality. That means that every particle is also energy, and the energy is also a particle. For example, they prove that the photons, initially they thought the photons that as I said, is the particles that compound the light. They thought it was energy, but they proved it was also particles. And the electrons that they thought at the beginning it was particles, they proved that it was also energy. Now we'll see later something that proves that. So quantum physics is the science that deals about the atomic and subatomic particles. The thing is, there is not yet any science that connects both the what is called classic physics, that is the physics of Newton, the material world, and the quantum physics, and also with the laws that deal with the cosmos and with the universe. That is the theory of relativity from Einstein. So there is not yet a connection. So everything that we try to explain to be a connection between them, so far it's just philosophy. Okay, so, but anyway, we are going to explain as much as we can from the science point of view, but also we will talk a little bit of philosophy today. Let's continue. Everything is energy. And for example, here we have the whole spectrum, the visual spectrum. As you know, we can, with our eyes, human eyes, we can see from red to violet. But as you can see here, there is much more than that. Up to violet, we have ultraviolet radiation and the X-rays, gamma rays, etc. Downwards, from red, you can see the infrared, radio waves, etc., etc. So you can only see a very little part of reality. That is only in the visual spectrum. Also in the auditory spectrum is similar. We only can listen a little part of the spectrum that some animals, like dolphins, for example, can hear some things that we cannot, etc. And you can see here also, all right, this is the same, but maybe in a different display, so you can see. All right, so everything is energy and it's all about frequency. It's all about frequency. It can be low frequency or high frequency, and it's just a continuous. It's not like, for example, when we say it's black and white, it's just part of the same thing. It's just a different level of frequency. And when we say, for example, cold and hot, it's the same thing. It's just a different part of the spectrum of the temperature. We tend to, because we live in a world of duality, we tend to say this is good or bad, this is cold or hot, this is pretty and ugly. So we always have, in our world, we put these tags of opposite things, but actually all things are only one. We just different grade. As I said before, there is an experiment that is famous in quantum physics that proves that every particle is also a wave. We're going to see this now. The duality, wave-particle duality. This is a little longer than, it's like 5 minutes or so. So just let's pay attention.
And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum.
Okay, so you have understood so far. So far it's simple, right? If you use objects, particles, and you have a pattern that is very defined, and if you any wave, energy, it could be water or could be any kind of energy, so they cancel each other. So some of them amplify depending on if they are in phase or not in phase, and they create a different pattern. So now, as he said, let's go quantum.
An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this.
Okay, so far, can you see that they throw an electron and the electron doesn't only go through one of the slides. It goes at the same time to both of them, and it interferes with itself, and it creates the wave particle. So then they say, okay, let's watch what is going on. Let's put an instrument to check where exactly it's going.
So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
All right, so as you have seen, when we try to measure where it is going, it behaves as a particle. So the observer is determining the observed object. That is interesting, right?
Yeah, of course.
So far we know that everything is energy, everything in the end is emptiness, almost. And so even the things that we thought they were particles, they can behave as energy. And so we can see the world from the point of view that is like we are used to, like everything is matter, particles, or we can see the world from the point of view that everything is energy. We can do like a matrix, no? It's not exactly like this, but something like this. Imagine you put the glasses and you see all electrons. And so let's go ahead.
Esteban, can I ask?
Sure.
Yeah, can you trust the source?
If I can trust the source of this experiment?
Yeah.
Yes, it is one of the most famous experiments in quantum physics.
Oh, okay.
Yeah, as I said at the beginning of my presentation, apart from that subject that I studied in the university. After, I have read some books, like for example, the Grand Design of Stephen Hawking is it was very, very inspiring. And also, for example, I have two more here. Can you see myself now? This is Conversaciones de Física con mi perro. Or in English, I think it's like how to teach physics to your dog or something like that. From Chad, this guy, Chad Ortel. Or I think this is only in Spanish. Desayuno con partículas, breakfast with particles. It's too light, too bright, okay. And in all the books, this is something that, I mean, they talk about this. So the world is an illusion. So when we say everything is matter, yes, we're right. When we say everything is energy, yes, you're right. It depends on the point of view you do it. And because everything is energy, including us, we are energy, and we behave, kind of behave as anthems. With we don't only receive those waves of energy, we also broadcast them. And as I said before, everything is about frequency. So when you are in a different mood, you vibrate at a different frequency. Last week, we were talking about emotional intelligence, and we were seeing that there are different emotions. Well, this is a kind of classification that is not always exactly the same of emotions, but more or less. And every emotion is a different frequency. So, in this case, I copy this again. It's the visual spectrum, but imagine that when you vibrate at a certain frequency, when you are, for example, having fear, you are vibrating a lower frequency. And when you are feeling joy, you are vibrating at a higher frequency. So in the end, when you take any decision, or when you decide to be in a more joyful mood, or if you are sad, you decide to be sad. I mean, some people might say, I don't decide to be sad. Well, occasionally you can be sad, but it is your decision is to keep in that mood. Okay, so in the end, it's just a decision of going high frequency or going low frequency. Okay, this is the part of philosophy, right? This is I told you that some parts of proof by experiments. That is a kind of philosophy, mostly my philosophy, but so we put this in brackets, right? But yeah, I believe that it is your life. It is very important in the frequency that you vibrate, and in the end is your decision. Okay, let's continue with more quantum physics. What about this? There is one chance in 140 trillion that the Earth should exist. There is one chance in 795 billions that life should have evolved on Earth. There is one chance in 89 billions that life should have evolved into mankind. There is one chance in 12 billions that mankind should have created the alphabet, that civilization. There is one chance in 6 billion that your parents should have ever met and got together. There is one chance in 90 million that you should have been the lucky sperm that fertilized your mother's egg. How lucky we are, right? That we are here alive. How lucky? How is possible that in so many billions and billions and billions of possibilities we are here? Well, in the experiment that we saw, when we saw that when you measure the particle, it collapses. So before it's just many possibilities, because the quantum physics is a science of possibilities. There is nothing for certain. actually there is a principle also that says that you cannot measure at the same time. If you have an atom and you have an electron around it, you cannot measure at the same time the position of it and the speed of it. If you measure the exact position of it, you cannot measure the exact speed of it, and therefore you cannot know where it will be in a second, or in a millisecond. Or if you measure the exact speed or momentum of this electron, you cannot measure the exact position. So this is the principle of uncertainty. All right. So everything in quantum physics is about possibilities. And if you get an electron, an atom, so there is a possibility, like, I don't know, 50% of possibilities that the electron is here. Maybe there is a 5% that is here. Maybe there is 1% that is here. Okay, so this is all about possibilities. And if you get 2, you have to multiply the possibilities of this times possibilities of this. And if you get 3, possibilities of this, possibilities of this. So imagine this is an exponential growth. The possibilities increases exponentially. And then there is 2 theories, because again, this is a part of the quantum physics that is not completely proved. But there are 2 theories. One is that this world is, I mean, you have the possibilities, and then when you see it, you measure it, it collapses, and it becomes one possibility, one thing. Or the other one, that is the theory of multiverses. That means that you only see one possibility, but the other possibilities still exist, and they are in a parallel universe. So according to the theory of multiverses, that is backed by scientists like Stephen Hawking and other famous scientists. So it is not proof, as I say, but it is a very a theory that has a lot of support. It says that all the possibilities are out there, and there is a universe where I'm here giving you this talk about quantum physics, or another universe where I am just, I don't know, I just decide to have a nap and I'm sleeping, or maybe another universe where I am not Esteban, I am Stephen. That is similar, but it's not the same. All the theories are out there. And so that is, again, philosophy. When you want something in your life, it's not about thinking about that will be possible. It will be possible that I do this. For me, the question is, the possibilities are already there existing, because actually the time, we'll see later, is another dimension. But the future is already existing in talking about dimensions, but we'll get there. So it's about that possibility is already there. So the question is, how do I get this reality to me? How do we, like, fish that reality and bring it to me? That is the question I do when I want to accomplish anything. Is not is that possible? No. Everything, is possible. Well, they follow the basic rules of the universe. But the thing is how to get that reality to me, how to go towards that reality, or that reality towards to me, right? Any questions so far? We will continue. Okay, so this is the Plato. This is the story. Do you know this story? Anybody knows this story? All right. So it says that there were some men that you have on your left, that they were kind of slaves, no? And they never came out of a cave. And the only thing they could see were the shadows of other things that they see, just the reflection of the shadows of other things that came from the real world. Mm-hmm. And when people told them about the real world, they didn't believe. They didn't want to believe. Actually, that happens. This is more about neuroscience. Many times when we believe something, and somebody presents us an evidence that this is not how we believe, many times because we want to keep our beliefs, we reject even some evidences. So that is this story, is that when they told them that there was another reality apart from shadows, they just wanted to stay in the world of shadows. And something can happen to us, something like that, because we live in a three-dimensional world. But do you know that Stephen Hawking, etc., say that there are 11, not 3, 4, 5, 11 dimensions, and we only see 3. It's like have you played the video game Pac-Man, the classic video game of Pac-Man? That is this this little figure in 2D that is eating balls, and there is some ghost, and then I don't know if you have played that. Anyway, if you tell that guy Pac-Man that there is a world in 3D, he wouldn't believe. He would still believe in a 2D world. So for us, for our mind that is a 3D mind, it's difficult to believe that there are so many dimensions, right? Okay, and what are those dimensions? Well, it's difficult to say all of them, but for example, one of them could be the time. That could be the 4th dimension. So in quantum physics, when something is not, the thing is, for particles that are subatomic particles like photons, that the photons, when they are not moving, they don't have any mass. So that they are a very special particle, right? So for particles like this, there are experiments that the time is just another dimension. The thing is that we are made of billions of atoms. And for example, if I tell you that a photon or even an electron can cross a wall, do you believe that? Yes, no?
Don't know.
Well, yes, so that is the tunnel effect. The electrons, or very small particles, can cross walls. Actually, we receive the light from the sun because of this quantum physics phenomenon, the tunnel effect, because our atmosphere is like a wall, and the particles from the sun shouldn't cross that barrier. However, because this is about mathematics, it's much difficult to explain for everybody, but just if you have an equation, the equation says that if you throw a photon here, it will reach until here. But if you put a wall here, most of them will hit the wall. But because of the equation, it says that they can go here. Some of them will go here, actually. It's a bit, in quantum physics, crazy things happen that are not possible in classic physics. So, and if I say that you actually can go against a wall and cross it, would you believe that? Well, what if I tell you that the answer is yes? But you would need to try as many times as the whole age of the universe. So the whole age of the universe, you try and hitting the wall, and once you could cross the wall. So if you want to try, you can start now. All right. So that is the 4th dimension. Well, and more dimensions. Now we enter again in my own philosophy. Another dimension could be, for example, the thing I mentioned before. Your vibration, your own vibration, how the mood you are, the emotions If you live the life in a state of love, let's say, or in a state of fear. This is just two ways to name. We say this is the same thing, but the different spectrum. But just the opposite ways would be love and fear, just to name them. So you can live the life in love, or you can live the love in fear. And the thing is, as we will see next week, when we'll talk about the law of attraction, when you vibrate on a higher frequency, the law of attraction will work more than if you vibrate in a lower frequency, in fear frequency. The law of attraction is, if you haven't heard about this, is that theoretical law that says that you attract what you think. But if you attract what you think when you are in a depression, I mean, you want something when you are into a depression, it's much more difficult to attract the things that you are feeling in a joy state, and it will be easier to attract the things. But again, as I said, this is just my own philosophy, and some of it is just philosophy. Other things that we have talked today is real experiments. But the point is, as we saw, there is a big spectrum that we, our sense, only can see a very teeny part of the spectrum, both in visual, auditory, etc. So we actually can measure very little in as humans. So the very truth that is this: the only true wisdom is in knowing you know nothing, Socrates said. So unfortunately, we know nothing, a little more than nothing, but very little comparing with all that exists in the universe. For example, do you know that in quantum physics also an electron, it's the matter and antimatter, so the electron and the antimatter of the electron can appear anytime, anywhere, but they show up so little time that it's impossible to perceive for us. It's like a very portion of a millisecond. So but yeah, actually particles appear and disappear anytime in quantum physics. I see Stephen that is like a kind of, he's having a headache like this. Yes, so yeah, quantum physics is not easy to understand. Hopefully in this presentation I have given you a little of inspiration to understand a little bit of what the quantum physics is. Because if you understand more about quantum physics, and if you understand that we live in a world that is not only matter, that is also energy. Actually, matter is energy vibrating a very low frequency. And so if you understand that everything is energy, and that your thoughts, we'll see next week more in deep, are energy, and we attract what we think, then you can make changes in your life. You want more positive, right? So I will stop here the presentation, and now we have a few minutes. If you're still here and you are not somewhere else, like what is going on here, you can ask me questions if you have.
It's very interesting. Thanks, Esteban.
Thank you.
You know what comes to my mind? You know, you talk about energy, and I don't know, you know, sort of like chi and prana and stuff like that. Whether that could be related, you know, energy, because energy flowing through the body, and I don't know. You talk about transmitting energy and stuff like that. I wonder if there's some kind of relation there. I don't know.
Actually, we emit all the time. We're emitting neutrinos that are like almost nothing, particles that are almost nothing, but we are all the time, our bodies are emitting neutrinos, for example. So you know, and of course the Wi-Fi, everything is energy. So we are surrounded by energy that we cannot even detect. And there is something called the antimatter that actually is not matter. Is that they detect in the universe that there is some kind of gravity, but there is nothing there. So it's something that is creating gravity, but that we, in this, from our sense or even from scientific tools, they don't know what it is. Maybe it comes from another universe, one of these parallel universes, could be.
Yeah, I've done some qigong work, and there's definitely some energy stuff going on there. So, but I have great difficulty moving it around the body, and other practitioners are much better than me. So, it's good. Get on a qigong course. It's good.
Yeah, it's something. It's an interesting concept. I don't know if there's anything in it.
A guy called James McRitchie operates out of Rodney Street. He doesn't do anything at the moment because of this lockdown, but as soon as it clears up, he'll be doing that again. The Energy Centre in Liverpool. He's a world leading expert in Liverpool on qigong. Yeah, I know. Very lucky to have him.
Any other questions, guys or girls? Yeah, it's normal when you first heard about quantum physics. It's like, what the hell is this? What are you talking about? So you need to process a little.
Have you got any book recommendations? You showed 2 already, but any super basic books to read up on it, to understand it?
Well, super basics. I don't know in quantum physics is super basics, but yeah, I mentioned 3. That is the grant designed from Stephen Hawking and another scientific design. He has also more books like the theory of all, no?
Of everything.
Of everything. Yeah. The one I say in Spanish, here in English, is How to Teach Physics to Your Dog. That is interesting. It's quantum physics explained in a kind of a funny way and an entertaining way. So, and this is I think it's only in Spanish. The Breakfast with Particles. Desayuno con partículas.
Okay. I'll have a look. I don't read books, but I listen to audio. I hope they have that as well.
I think the Spanish is interesting because you can do Spanish and quantum physics at the same time. I love that. Like me in the sauna, I will be lying there in the sauna doing sit-ups, counting in German. Why not do 3 things at once? Because I'm a man doesn't mean I can't do that.
You should be juggling at the same time.
No, I can't juggle at the same time. Tricky. Love doing more thing at once.
Maybe for the next language exchange, we can do Spanish and quantum physics, and then your head will explode.
You do this presentation next week in Spanish.
Say again, sorry, Esther?
You do the same presentation next week in Spanish, and we can see how much.
I could do, yes, but I don't know if everybody coming to language exchange would be happy with that.
I could understand that.
The law of attraction looks quite interesting next week. I've looked at that for the past couple of years, and again, I think there's something in that as well.
Yeah, for me, the law of attraction, the explanation of the law of attraction is in the quantum physics.
Okay.
That's it. Why I want to relate, and next week I'm going to talk about the law of attraction to connect them.
There are some parallels there because I think one of the I get the idea. The ethos of the law of attraction is if you're trying to do something, you can try too hard. It's like being observed. If you're looking at something that's going on, it isn't going to happen. But if you stop looking, suddenly things start happening, and it's that kind of thing that's very. I can see it's rang some bells with you there, Astefan, hasn't it? You stop looking, and suddenly things get better, or put less effort into doing stuff.
Yeah, that experiment's really curious. The way that just the observing cancelled out the effect. It's I don't any sort of reason, any sort of idea why that might be.
Well, actually, we receive, there are like billions of bits of information every second comes to our, from different senses to us, and we can process only a very little fraction of it. And our mind just creates, like, fills the gaps. So what we see like so real is our mind is creating most of it, like and yeah, and in quantum physics, when you, I mean, it's not, you cannot extrapolate directly from quantum physics to classic physics. Like you say, the observer is defining the observed in, you know, in this experiment with the electron, and then in physical reality it will be the same, but not directly. But it is very inspiring, and possibly has something very has a lot to do with, you know, like from, well, not only quantum physics, from psychology and neuroscience, with our values, with our beliefs. There is something called sistema reticular, I don't know in English, reticular system or something like that, that selects from all the information what it is important for us. For example, when there is like a lot of noise in a room and suddenly we hear our name, cling, we pay attention to our name. Or, for example, a mother, there is a lot of noises and suddenly the baby, and for example, is sleeping, no? And even there are noises, but the baby is crying and wakes up. So we have this reticular system that selects what it is important for us. And that depends on our beliefs, on our values. So there is an experiment of the monkey. Have you seen that experiment? If not, we can see next week, or maybe now. Let me check.
No, it's good. I like that.
I
So
like monkeys.
Okay, and actually, I already told you the surprise. So we'll see it next week. Yeah. So yeah, the thing is, we pay attention only what we believe it is important, and there you know, there might be things that comes in front of you and you don't notice because you are paying attention to the things. All right. So for example,
or is that the monkey where suddenly one runs through, like people playing ball and suddenly a monkey runs through?
Exactly, that one. That one, exactly. Or for example, I can tell you, okay, look behind me and see the things that are green. Okay. And now I stop my video and you are going to tell me the things that are blue.
Yeah.
Okay. Now, oh, you didn't pay attention to the blue things. You were paying attention to the green things. So, for example, this is blue. So yes, there is part quantum physics, part neuroscience, but yes, there is a big importance in what are your beliefs and what you pay attention to and how you believe the things are and how you see things.
But since you said like quantum physics is not related to physics, is it recognized as a part of physics or is it treated as something else?
No, yeah, there are physics, but the thing is, so far it hasn't been possible to connect the classic physics, that is the classic Newton's laws, no, when you make a there is an object that you put like a force, they will move in the sense of the force one. This, the apple falling because of the law of gravity. This is the classic physics, and there are some laws on the classic physics, and there is the quantum physics that it has so far its own laws. The thing is, so far the science haven't been able to connect the two of them. So there are some rules for very small objects and other rules for bigger objects. And then the way you connect them so far is only philosophy. It's philosophy.
Okay.
Can I say something?
Sure.
Right. No, it's just that in my experience, a lot of people are too afraid to say of the things that have happened to them because they're so weird.
I didn't get the point. So people are afraid to say things because, sorry.
Some of the weird things that happen to people
okay.
are kind of a little bit on the untellable side because they think you're crazy if you tell them.
Okay, I get your meaning now. Yes. So yeah, many people has some, I don't know, like see things that weird things as Sue says, and I know Sue and she knows what she's talking about, and yeah, people don't tell because other people might be saying that they are crazy. Exactly.
I think there was an experiment a while ago, I don't know, where they put a dying person on an extremely exact scale. And the second that person died, the person got lighter. Now, obviously, there's physiological process going on, but the theory was that the spirit has left that person, and I think that touches on that as well a little bit, I suppose, that the energy that makes a person has left, and that's why it physically got lighter, which I find quite interesting. That's
the energy's gone. Yeah, I think there might be something in that. Yeah.
There is actually a film called, I think it's
21 grams.
That is when a person dies, is the weight it is lost from that person.
Oh, right. Yeah, there's a film about that. I didn't know that. Oh.
Yeah, it's called 21 grams.
Mm.
Okay. Bueno, chicos, it's almost o'clock, so I think it's a good time to finish. And I hope you have enjoyed and learn a little bit, get a little of inspiration. And yeah, see you next Saturday if you want. Wait a moment. Another thing. I created a survey, so you give me your feedback about this session and how we can improve, or how I can improve, or some other topics that you would like to talk about. It might take around 5 minutes to, depending of how long your answers are. So I leave the link there.
Thank you very much.
Yes.
Yeah.
Thank you.
Yeah,
Thanks,
thank you.
Esteban.
Thank
You're
you.
welcome, everybody.
Thank you. Okay, bye-bye.
Have a nice
Bye.
weekend.
Bye.
Bye.
Have a quantum weekend.
Same
Bye.
time.
Weekend, yeah.
Bye-bye.